Hey, good morning again. This is lesson 4.2, patterns and linear functions. Let me share my screen with you. All right, students. Today's lesson 4.2 is patterns and linear functions. It is page oh goodness, 50 something. I turned the page here, I apologize. Let's see. 255. I forgot to write that down, sorry. Yeah, so it's page 255. Okay, not that that was terribly important. I guess you could find it without that. Anyways, so let's go over the details. A pattern is an ordered form that appears naturally. An ordered form that appears naturally. Let me give you an example. If you're looking at a flower, you'll notice that a flower always has like a circle, and that circle always is represented with like petals. Okay. Now, depending on what the flower is, that flower may always have the exact same number of petals. So here's a flower with 1, 2, 3, 4, 5, 6. No, 1, 2, 3, 4, 5, 6, 7. I apologize. So there's 7 petals on this flower. So let's just say that whatever flower this would happen to be, if it was a real flower, always has 7 petals. So that would be a pattern because it occurs naturally and it always happens to be that way. Okay. There's also clovers. Um, most clovers are 3 leaves. Occasionally, I guess people get a 4-leaf one. I'm not even certain if that's a myth, or if there's like a hybrid one. There, an anomal, and that word, an anomaly, one that just pops up every now and then that happens to be quote unquote the lucky clover. But the idea is that something that occurs naturally. Now, when you are looking at charts and data, now they're not as natural as like the number of leaves in a flower, but you might see a trend of things that happen naturally. Okay, like for example, the growth rate from age 12 to age 20. Okay, basically kind of like the borders of teen years, because 12 is the last year where you're not considered a teenager, and 20 is the first year that you're not considered a teenager in terms of going up. So you would see that a growth rate would probably occur at a very like linear straight rate, okay? Meaning that um, if you were to chart it on a graph, it would probably, look something like this, okay? Now, it may not be perfectly linear, the growth, like in terms of like height or whatever. Um, some people grow like in really like fast spurts, and then like they just grow super tall and then they just sort of even off. So it might be something like this: grow really tall and then sort of even off. So maybe like at age 13 a kid like starts growing super tall, and then they just sort of gradually grow taller up until they're 20. Okay. I know for myself, um, I had gotten measured, I think, for my cap and gown for my high school graduation, when I was 18 years old, to, obviously to graduate. And it said that I was 5 foot 11 inches tall. When I was 21 or 22, I had to get measured again. I think, I don't even remember if it was for a suit. I think I had hurt my back, and the doctor wanted to measure me just to, be certain that I was okay. I had grown 2¼ inches. And people say that, oh, well, once you're 18, you stop growing, but that's not necessarily true. Height can go all the way up until the age of 25 before a person stops growing. That's a little side note here, but again, just giving you the idea of what a pattern is. It's an ordered form that appears naturally. And even if you're just charting the data in numbers, then usually you will see a pattern. or an ordered form that occurs when you like take the numbers and put them onto a sheet. Okay? A linear function is a function that creates a line on a coordinate plane. Now, in order to be considered a function, this line would have to be non-vertical. Now, vertical simply means like this red line here that I'm coloring in goes straight up and down from top to bottom. Okay? So if the line does not go straight up and down, perpendicular to a flat surface on the bottom, then it would be considered a linear function. If it does go straight up and down, it would still be linear, but it would not be considered a function. We can go into more detail on that in later lessons. Just need a little tidbit for you to know. Okay? Now, what is a function? Now, the word function has a lot of uses. I'm not thinking so much about the English usage, but in mathematic usage, let's focus on this definition. It is a relationship. I know I wrote that like it was one word. It's two words. A relationship between numbers in which there's exactly one output, and I wrote the letter y next to that, for every input. I wrote the letter x next to that. Now, the reason I used x and y is because most of the time when we are talking about relationships, we're talking about how to graph them. Now, in order to graph them, those relationships have to have values that relate to the graph. Now, the typical graph values are x and y, okay? X means your horizontal line, and y means your vertical line when you're graphing information. But again, we're not going to be doing graphing on this specific lesson, but I want to talk about making a table of values because a table of values is what creates the graph. A relationship can be represented by a table of values. Now, I wrote a table here. Normally with a table of values, you label it at the top, x and y, and then you put a list of numbers here, okay? The x numbers usually control what the y numbers are, okay? But you might have noticed in this particular one, I just put words. So let's look at the words that I put. For x, I put independent, and for y, I put dependent. For x, I put input, for y, I put output. For x, I put domain, and for y, I put range. And for x, I put cause, and for y, I put effect. Now, there's more pairs of words that are represented by the letters x and y when talking about graphing, but these four are used quite a bit. Now, the ones I really want to talk about for today's lesson are independent and dependent. Now, for our purposes, you'll probably get it down the fact that this is just your x and your y value, okay? And that is true. Those are your x and y value. But beyond that, I want to talk about what do they mean. Your x value is called your independent variable. Independent variable. Now, when we say independent, we mean that it's not controlled by something. Like if you say, Mom, I want to be independent. And she's like, fine, go live on your own. Get a job. Who's going to wash your clothes for you? Who's going to even buy you the clothes? Okay? Now, not getting into people's family politics, but the idea is that the word independent means not controlled by anything. Dependent means that something or someone is controlled, okay? So if you're in a dependent relationship with your parents, and that means you need for them to provide for you, to give you the food and clothes and things that you need, to provide a place for you to live, that type of thing. Now, some people may help their parents with those things, like if you get a job, maybe you can use some of your money to help pay rent or pay mortgage. Maybe if you, maybe you don't have a job, but maybe you can help with chores and things like that around the house. But bottom line is you're dependent on the parent to provide the things for you, even if you help to make those things possible. Once you're not depending on the parent, then you're independent. So you are the person who makes sure that you have food and clothes and a roof over your head. Now, I know with the way that money has gone up for years and years, the values of housing and apartments and rent and things like that are just very, very expensive. Um, and a lot of young people I've noticed when they get independent, looking at that word again, they try to move away from the coast because houses are always cheaper. The closer you are to the ocean, the more expensive. Regardless, these are just things for you to think about as you grow a little bit older. But if you make a plan, you can usually do what you want as long as you're willing to discipline yourself to make the steps. Part of being independent, self-discipline. Okay, so let's look at how this works mathematically. So an independent value, we can consider that as a random number that is placed into a table. Now, whatever is done with that random number, um, when it is compared to the number here, it usually, this number depends on what that number is. Now, let me show you a relationship table here for birthdays. In this case, X represents the month and Y represents the date. Okay, now we have 3-2, which would be March 2nd, 5-4, which would be May 4th, 4-3, which would be April 3rd, 7-1, which would be July 1st, 9-17, which would be September 17th, and 3-5, which would be March 5th. Now, normally I do this in a classroom setting, like I actually ask kids what their birthdays are, but if I guessed and got one of your birthdays, awesome, that would be great. But I didn't look on your files or anything if I did get it. Just the point that I'm trying to make is this would be a relationship table. Now, the Y number here, in a sense, represents a date in a specific month. So it does kind of depend on like what month. Like for example, I have 9/17 here, which is September 17th. Now, if I had like April 17th, which would be 4/17 instead of 9/17, then even though this number is the same, it still is dependent on the month to tell you where it pops up in the calendar, okay? Because on any given calendar, since there's 12 months, then the number 17 occurs 12 times. So to get the right one, it has to depend on what your X value is. If I'm just charting, again, month and date. Now I wrote a little question here in the note. Can the X value repeat? Well, let's take a look. So I have March here, and I also have March here, okay? Now, the interesting thing, obviously, it could repeat. Now, let's just say that all of us in class decided to talk about our birthdays and put it on a chart like this, okay? Randomly, any two of us could have the same birth month. And even though it's less likely, two of us could have the same date. I actually, one time was teaching a 6th grade class, and I had two kids that were born on February 29th, which is the rarest possible date to be born, but it doesn't end there. They were not only born on the same day, they're the exact same age, and they were born in the same hospital on the same day, and they were both students in my class. So items like that, occur very rarely. That's one of the reasons why I remember it. Um, but but generally speaking, if you just have a random group of kids, most of them will not have the exact same birthdays. Um, Occasionally, you're going to get some that will have maybe the same birth month, and it's not impossible. I mean, I know a handful of people that have the same birthday as me. Just people that I've talked to. I have my cousin's son, kind of like a nephew to me. He's got the same birthday. A couple of other friends, so it does happen. But I want to point out something. The X value here, the independent value, would repeat or could repeat potentially in this setup. Now I want to show you a different relationship here. It's a relationship table that happens to be a function. Now this one's similar to the field over here. It's the order of persons that are asked about their birthday. and Y would be the birth date, just the day only. Since I didn't want to have a table that had 3 columns, I just picked the day as opposed to the month. So the first person asked was born on the 2nd of a given month. The second person was born on the 4th. The third person was born on the 3rd. The fourth person was born on the 1st. The fifth person on the 17th. The sixth person on the 2nd. The seventh person on the 5th, and so on. Okay. I noticed my numbers were almost the same as on this table, but I changed one. That one should have been 5 and it's 2, but that's immaterial. Basically meaning it's not important. But I wanted to show you a point here. In this relationship table, the X number, the independent value, represents just the number of the order that people were asked what their birthday was. Now, I'm assuming that if this was a real group of people that I talked to, I just sort of like fabricated this just for our purposes. But if we were sitting in class together, I literally would have done this and would have been like, okay, Hector, when's your birthday? Okay, Evelyn, when's your birthday? You know, things like that. So continuing on, so the birthdays here, the first number, or the X value, is the number in order of which I asked people. The Y value would just be the day only. So let's look at the question. Does the X value repeat here? Now it does not repeat here. So let me ask it a different way. Could the X value repeat in this particular table, provided that I went by the same rules that I discussed with you? The order of persons asked and the birth date only. Yes, it could repeat. No, actually, it could not. That was a trick question. Now, let me think of it this way. Could I ask 2 first persons? That doesn't even make any sense. By definition of what first means, would mean that would be the beginning person that I talked to. I could not talk to 2 beginning people at the same time. Okay, you're the first one and you're the first one. No, it would be one of them would have to be the second place person. Okay, so in this particular one, it forms a function. Now, in a function, note here, a function will never repeat its X value. Okay, what do I mean by that? Now, in this table here, the number 3, representing the month of March, repeats. Okay, even if it didn't repeat, even if I didn't put this number here, it very well likely could have been if you asked any random group of people what their birthday is, the 2 of them would have the same month, because there's a 1 in 12 chance of that. Now, the same month and the same date, that's a much more rare occurrence. Even at that, it does happen. But, and then like I said, once in my life, you had, I had 2 students in the same class, same month, same year, same date, and it happened to be the rarest possible day of the year to be born. That was special. Okay? So, and I say that because February 29th, the day that they were born, is leap day, which only occurs once every 4 years. That's why it's like such a rare thing. Okay, so so the X value here cannot possibly repeat unless I change the rules, okay, and said that, okay, well, I'm going to ask 2 people at the exact same time and they have to answer me at the exact same time. But even like if there were twins here that were born on the same day, okay. Oh, and by the way, those 2 kids that were born on the same day were not even related. So that just wanted to clarify. It wasn't like tricking you, like, oh, they're twins. So like, well, yeah, of course twins are born the same day. So unless I change the rules, then the X value here could not repeat, okay? Now, in a function, if the X value repeats, then it would not be considered a function. It would just be considered a relationship. Now, both of these tables are relationships, but only this one is a function, okay? Now let me ask another question. What about the y value? Could the y value here repeat? And again, the y value is the birth date, or the day that a person was born. Well, there's more of like a 1 in 31 chance. Um, some of them maybe have a little bit more likelihood because not every month has 31 days. Um, but typically, yeah, it's not that hard to find another person who was born on the same day of the month, even if they were not born on the same month as you. Okay? So even if I had twins here, for example, um, and let's say one of the twins was born on the fifth day of the month, and the next twin was also born on the fifth day of the month. But if I were to add those values here, I would have 8, 5. It's not saying that one was born on July 5th and the other was born on August 5th. That's not what that means. It means the seventh person that I asked the question to was born on the fifth day of a given month. The eighth person, who may be the twin to the seventh person, was also born on the fifth day of a given month. Okay? On this particular one, it doesn't say what the month is. It just says what the date is. So my point is, in this particular one, it's a function because following the rules that I've set up, order of persons asked and birth date, then there's no way that the x value would ever be able to repeat. Okay? Now I hope that this makes this pretty clear. As you look through lesson 4.2 on page 255 and following, please read through and look at some of the examples, and it'll really help you to understand a linear function. Thank you very much.